Okay. Just pardon my writing in that way. So we are talking about binary operations today. Now, I'm going to be fast with the class. Binary operation is a special mathematical operation that combines two or more regular mathematical operations. The mathematical operations you are aware or you are familiar with are additions, subtraction, multiplications, division, square root. Let me just use square root of n square, n cube. All of these are the normal mathematical operation you are familiar with. But the binary operation is a kind of operation that can combine any two or more of these. It can repeat several of these. Yeah, it can repeat several of that. So most times when you see a binary operation, it's a special kind of notation, like something like this. Something like this. They can do something like star, this kind of operation. They can do something like this. Different things. These ones are binary operations. And each of these will be defined. If they are giving you this one, I want to underline it now. If they are giving you this one as a binary operation, they will define it. You will see how it is defined, and based on how it is defined is what you are expected to use to solve a particular given question. For most of you that are not offering further math when you are in secondary school, so you will find this topic a bit strange or foreign in a way, but just pay attention to it. But I think I will have to be as fast as possible to be able to cover necessary part of this syllabus. Okay, so let me give you an instance example. If you have this star b, or plus, it doesn't matter anyhow, is equal to, they will give you the definition of this, maybe ab plus a plus b. This is what it is. So anytime you see A and B combined with this particular binary operation, what it means is that you first multiply A and B, you add A, then you add B. What are your A and B? Your A and B, or any letter at all, it can be P and Q, it can be M and N, it can be any letter. And of course, by now, I want to believe that you already have past questions of JAMP questions that you can operate with. You will see questions like this there. And I want to encourage you to post questions, because we cannot cover everything by this limited time we can't. So the more you are able to practice questions, the ones you cannot solve, send it across. We'll look into it and return with an answer or possibly an explanation. And if we think it will benefit others, we can easily, do a brief explanation of such on a platform like this during our online teaching. But you have a platform, you have a WhatsApp platform where you can send your questions to. If you can't solve them, you have people around you. But if you think it is necessary that you post it, and I think I will do it in such a way that you will have time to ask questions too. Or in the past, students have not been asking questions. So I will encourage you to also ask questions. So if you have this kind of an arrangement, now we can just start with a simple operation like, if all of this is given, they can say do 2 star minus 5. Okay, something like this. What do you think it will be equal to? So if you have 2, this operation, this is a binary operation. So your A is 2, your B is minus 5. It can be any letter. It can be minus 2, minus 5. But here it is 2, not minus 2. So 2 and minus 5. How do you operate it? The way you see, let me use a red line now. The way you see these arranged and these ones arranged is the exact way you are going to arrange your numbers too. So what it means is that AB simply means 2 times minus 5. So you have 2 into bracket minus 5. That is the multiplication. Then plus A, which is plus 2, and then plus minus 5. I want to encourage you, don't truncate these arrangements. In binary operation, order is of high requirements. You have to learn to arrange your variables in order. Don't go and put B where A is supposed to be. You will get a wrong answer. And JAMB exam in less than 4 hours, 3 hours something, you are done. And that will determine what will happen to you the next year. So it's a whole year thing. So I need you to pay attention to all of this. Any mistake you make on the day you are writing the exam will affect you for the next 1 year. So if you pass, that's the end of story. You are facing another level of achievement. But if you don't pass, it's a whole lot of trouble. That is the reason why you have to concentrate on this. And I can tell you for free, we cannot cover everything online. We cannot cover everything. So do more to study on your own. Get into past questions, the ones you understand, solve them. The ones you don't understand, send them across. Let us help you, because the reason why we are here is to help you. All right. So I will not talk too much. I'll just go ahead. 2 times minus 5 is minus 10, of course. So you have minus 10. Can I do most of these things, without just doing many studies, so that I can just give you final answer? Minus 10 plus 2 is minus 8. Minus 8 plus times minus is minus. So minus 8 minus 5 is minus 13. So that's your answer. Minus 13. All right. That is that about that. There are several questions, and I can tell you this symbol is not unique. This binary operation symbol is not unique. But anytime you are given, you will be given what you need. You'll be given the interpretation, just like I underlined the red. Okay. So in my own interpretation, this particular binary operation has been well defined. So anytime I have any 2 number, this is what I'll get. All right. Now, and because it is JAM, they can give you in different terms. If you need me to, please, I need you to write fast so that I can quickly switch out, because I'm using a small device. So the screen is not that big to make several partitions. All right. So I'm going. I want to give a very intelligent question here now. Look at this. If 3, okay, let me not do that yet.
Sorry for the interruption. Students, can you all understand what is teaching you the solution he provided earlier? Do you understand?
Yes, sir. Yes, sir.
Okay. If you don't understand, please feel free to ask questions. Don't be shy. Don't be. You are here to learn. So it doesn't matter if others know it. If you don't know it, just ask questions. Okay.
All right. Thank you, sir. So I want to move to the next one. Okay. So here, this is a very technical one. Maybe I should just do one more example before I go into the technical aspects. But because of time is why I'm just trying to compress a lot of things. So let's say that based on the previous definition that I have, if star B is given as AB plus A plus B, okay, and let me use 7, okay, 7 star Y equals, and I need you to pay attention to this. 7 with this is not a star actually. You just give it any name you want, because there is no uniqueness to it. Is equal to 31. Find Y. Find Y. So something like this. What do you think we can get? How do you think we can get y? The first thing you need to do is arrange 7 and y in the order of a and b. So the solution is simple. Or do I have somebody who can tell me what to do? Do I have anyone who has an idea what to do? Okay, let me not.
I can try.
Oh, good. What's the name?
Roots.
Ruth. Okay, please go ahead. Let me see how you can demystify that. Go ahead, please.
The 7 plus y, 7 star y equals 31. To
Okay.
find y, it will be 7y plus 7 plus y equals 31.
Beautiful.
Then 7y plus 7 equals 31. 8y
Beautiful.
plus 7 equals 31. Then that will be 8y equals 31. Then we
I love that. I love that. And then our answer
is 3.
will be, because if you hello, can you hear me? Sorry, okay. I want to be sure that you can hear me. So here I'm saying that thank you very much, Ruth. You have done well. So we just arrange our 7 and y in the order of A and B. So 7 plus 7 into, okay, let me just first write it out, which is supposed to be 7y plus 7 plus y, and you should get 31. That's the answer you should get. Then collect like terms, of course. 7y plus y will give you 8y. So let me just write that up. 8y plus 7 is equal to 31. That means 8y is equal to 31 minus 7. I need you to learn to process these things fast. That is why I want to be compressing a lot of these calculations so that it won't look like we are doing a GSS3 work. I know for you to have picked mathematics in JAM, there are some level of proficiency you have already attained in the secondary school. So I may not have the luxury of time to be doing all the step-by-step manipulations. So from here, of course, your 8y will be equal to 24. And by the time you divide both sides by 8, then your y evidently will be equal to 3. All right, you can check this, replace y with 3, and then arrange it and see whether you are going to get the same answer. All right, very important. Somebody is disturbing my screen. Is that a chat or something? If you disturb my screen, I will know, because it will bring your name as you are annotating on it. I chat. So don't disturb my screen. Okay, let's move on. So these are the possible things you can see. There are more to this, different, but like I told you, there is no uniqueness in the binary operation. But anytime you are given a particular binary operation, they will give you the interpretation of that binary operation so that you can work along with it. Okay, so the next thing I want to talk about are the properties of binary operation. There are properties of all these things you are talking about. Though in a way, based on what we have done, based on what we have done so far, some topics that we have covered, we've covered numbers, different types of numbers, whole numbers, even numbers, prime numbers, real numbers, integers, and all of that. They can ask question based on some properties, and this is the reason why I'm going to introduce you to the properties of a binary operation. The first thing you are going to be noting about the properties of binary operation is closure. Closure. What is closure? I'm going to explain it to you, but I just want to stay on this screen and get some things. You can't connect to the video. You don't need video. If you can hear me, you don't need video. It's just on your screen. Everything will appear automatically on your screen. You don't need video. Okay. I want to see who sent the message. Blessing, Adegoke. You don't need video. All right. If you can hear me very well, just go to the major screen. That is where you will see this, the major screen. Once you log in, the first page you will see is where this should appear automatically. So it's not that I have a video. I'm not even showing my own video, but you should see my screen on the home page. All right. So let's move on. So I was talking about closure, and I'm going to list, maybe I should just quickly list those properties for you so that you can read up on them in your various mathematical textbooks that you have. Okay, so I'm going to list the properties out for you. The first property, I call it closure. Then the second one is called if A star B is equal to B star A, it is called commutativity. Commutative property. This is closure property, commutative property. Then we have associative property. Associative. That's why I'm saying this, because I think my screen is not acting fine. Associative, from the word association. And the fourth property is called distributive property, from the word distribution. Distributive. Okay. Then the next one we have identity property. Closure, commutative, associative, distributive. This one is VO. Let me see if I can write it well. I know it will form. Okay, let me just put it well. TIVE, distributive. This one is E. See my lettering. Distributive. Yeah, my E comes fine now. Okay. Then we have identity property. And then the last one, inverse. Property of inverse. So once we are able to finish all of this, that means we have concluded binary operation. For a particular binary operation, after you know how to manipulate your way to get answer, they will test any of this, some of it or all of it. It depends. So this is the next thing we should talk about. Closure. What is closure? I will tell you what closure is. Closure is the property that says that when you operate on a particular set of number, your answer should also be part of that set of number. I'm going to go back to the previous slide and we're going to see an example of that. When you operate on a particular set of number, that's the property of closure. Your answer that you will get must also belong to that set of number. Once that is satisfied, then you say you have closure property satisfied. You have closure property satisfied. So let me quickly go to the previous slide. Like in this case now, we talk about 2 and minus 5, and then we go minus 13. This now is about integers, whole numbers, just whole numbers, whether positive or negative. These are whole numbers. So this is already set of integers. I picked 2 from positive number, I picked minus 5 from negative number. What I'm interested in is, will I get a whole number? If I am able to get a whole number, because 2 and minus 5 belong to the set of whole numbers. 2 is an even number, 2 is a positive number, minus 5 is minus 5 is a negative number. because there is no, well, it's possible. It's an odd integer in a way. It's an odd integer, but we don't even need that. 2 and 5 collectively, which set do they belong to in the set of number? They belong to the set of integers. That settles our case. Then my answer, does my answer belong to the set of integers? The answer is yes. So I pick any integer, I operate it based on this binary operation, and I'm able to get another answer, which is also part of set of integers. Then it is closed. That is what they call closure. Let me go to the next one. That's what they call closure. Okay. Now look at this next one. Here, I operate with 7 and 3 because I was able to get my answer as 3. I operate with 7 and 3. So I can say now I'm restricting my catch. I'm only working with set of positive whole numbers. That is natural numbers. Natural numbers. So if I pick any 2 natural numbers and I'm able to operate them and I'm able to get another natural number, then I will say it is closed. It is possible, very possible, that I will operate 2 numbers on themselves, and I will not be able to get that particular set of number. Maybe we should quickly check that under the property of closure. But in this case now, it is closed because I use 7, positive whole number. I was able to get 3, positive whole number, and my answer is 31, positive whole number. So this is a set of numbers that I've used. So both the numbers and the answers I get at the end of the operation are part of positive whole number. So I will say this binary operation is closed. Is there a possibility that it will not be closed? Yes, there's a possibility that it will not be closed. But it depends on the kind of question they are giving you. And I'm going to show you one now. I'm going to show you one. Let's do this together. Let's do this together. So I'm going to pick based on closure. Now I just want to set an example based on closure. I still have someone troubling my screen, and I don't know who that is, but fine. Let me go to a new example now. Look at this. If A star B equals A plus B over AB. A plus B over AB. Let's see if you are going to have, for this kind of a thing now, maybe A and B, A comma B is element of course, natural numbers. Now we want to check whether this binary operation will be closed. If A and B belongs to the set of natural numbers. Natural numbers simply means positive whole numbers. Let's check if there will be closure. Pick any 2 natural number, anyone. We want to check whether there will be closure. All right, because they can ask, is this binary operation closed under the set of natural numbers? That's the question they will ask you. Because I may not be able to write everything on the screen, but you need to pay attention to this. And I also believe that the video is being recorded, so you won't have issue with listening over and over to be able to get. Pick any 2 natural numbers. I will closure. Any 2 whole number. Should I call names? Anyone can just give me 2 positive whole numbers that you like. Probably between 1 and 10, so that we don't work with 2 big numbers. Eniola Shobayo, if you can hear me, you can unmute. Oh, okay. Suliat, don't worry, just go on.
7.
7 and
5.
I need 2 numbers. 7 and 5 is fine.
So
let's just check 7 and 5 out. Oh, someone is trying to say something? Yeah, who is that? Is it Suliat? Okay, I think for the sake of time, let's just manage 7 and 5. Any two whole numbers that is possible, that is positive is fine for us. So your A can be 7 and your B is 5. Let's try it. Any two whole number is fine. 7, and then we have this, and then 5. We are going to operate it. Let's see. So that would be 7 plus 5 all over 7 times 5. And what you are going to see is you are going to have 12 over 35. 12 over 35 is not a whole number, it's a fraction. It's a fraction. So our conclusion is that this binary operation is not closed. It's not closed. This one is not. That's your conclusion. It's not closed. That's how to check for property of closure. Your two numbers you use, they are whole numbers. When you operate them, the answer you get is not a whole number. So that means the property of is not closed under the set of natural numbers. It's not closed. That's how to check for closure. You will get an answer, fine, but they want to know, does it satisfy that property? So it's not closed. It's not closed. And I'm still going to use this same set of numbers.
Excuse me, sir.
Yeah, go on. Go ahead.
Me, sir. How
yes,
about,
I can hear you.
5 and 1.
5 and 1. It's not closed.
And 1.
You can try it. If you use 5 and 1, you get 5 plus 1 is 6. 5 times 1 is 5. So 6 over 5 is still a fraction. Yes. Yeah, it's not closed. It's not closed. Any two numbers that you use, it's not closed. So you can see that it is not all the binary operations that are closed. It's not all binary operations that are closed. It depends on when you try it out and you are not able to get it. Okay, and that does not mean that, and I like this scenario now. Don't just try just once and say, okay, because of one trial it's not closed. Most times you can have several other ones that when you try it, it will work. All right, it's possible that when you have other ones, it will work. Let me give you an example. If I use 2 and 2, it will work. 2 times 2 is 4. 2 plus 2 is 4. 4 over 4 is 1. That is what? Whole number. So if you had used 2 and 2, you would say it's close. But you have to try several other numbers. So now the reason why I decided to conclude at the first instance is because I know already that all the natural numbers will not work. Even if I use 5 and 5, 5 plus 5 is 10, 5 times 5 is 25. Do you see? So all these things have to be taken into cognition. So that is the property of closure. You can try several other examples on closure, but I want to stop here on closure. Let me quickly move to another property. I want to believe you all understand that. If you still have issue, let me know. I can treat it before we move ahead. This is closure. If you want me to go ahead, just say hi so that I will know that I'm not talking to myself. Hello. Hope I'm not lost out of Zoom. Oh, okay. Hi. Oh, nice one. Nice one. Olaba Missy, thank you. Ruth, thank you. Okay, so I can move on now. All right, let's talk about the next property. We've spoken about, let me bring it up again. It's nice that we are doing all of this. We've done closure, and we all understand closure. So let me just mark it. Now let's talk about commutative property. Commutative property. I'm going to use that last example to demonstrate commutative property. But I can also tell you that it doesn't work like that for all the operations. All right, it doesn't work like that for all the operations. So let's go for commutative property. All right, so for commutative property is what we are doing now. Now, for commutativity, commutative property says that when you have a binary operation like this with 2 letters. And then you decide to interchange and you put the second one first and you put the next one, you are just playing around it. Once you are able to get the same answer, then you will conclude that it is commutative. This is the property of commutativity. A star B must be equal to B star A. That's what they call commutativity. But it doesn't work like that in all situations. It doesn't work like that in all situations. The last example we solved, I'm going to bring it up. So if I say 7 star 5, because I've defined this binary operation as in previous example. So sorry, I think there's a renovation going up in my area, so it's affecting, but just manage. I will speak loud so that everybody it can be well understood. If you use this, and then you get 7 plus 5 over 7 times 5. This one will give you 12 over 35. What if we decide to interchange? And
hello, sir.
Put 5 here.
You
Yes,
have
sir.
less than 3 minutes to go.
Okay. Good.
Then we start
Fine.
the physics class.
Physics.
Okay,
good. So if I decide to say 5 times 7, because I have less than 3 minutes and I'm going to be concluding very fast, that will be 5 plus 7, all right, over 5 times 7. You will still get 12 over 35. Once this is achieved, you will say that it is commutative. But if not, you will say it is not commutative. So these are the properties we are going to explore today. Go into your JAMB question textbooks, or if you have it as ebook, solve question on these 2 properties and ordinary operations that we have done. So we've been able to do 3 things. So next class, what we are going to be concentrating on now will be associativity, distributivity, identity, and inverse. And once we are able to get that done, then we have concluded on binary operation. Okay? If you have any questions, please ask, because I'm done for this hour. Like I said, I want to give you time to ask questions, but if you can't ask question now, feel free to send your question into the WhatsApp that is always giving you notification. It will get to me, and then from there we can take it up, possibly address it in the next class. Thank you very much. So I'm waiting for your question in 1 minute, and if there is none, good for us, we are done for today. Okay, I think nobody is asking questions. So Mr. Jatsu, we are good to end the class.